Now, there are a few other ways to describe circular motion due to the fact that when you travel in a circle, you are necessarily completing something that is cyclical, meaning if you start at position A and you continue traveling long enough, eventually your position in Cartesian coordinate space is exactly the same as where you started. That would be one cycle. And you can keep doing that. And you can count how many times you go around the circle. There are a few characteristic quantities then. Capital T is called a period. And it refers to the delta T, so the amount of time that passes for one circle. So if you're traveling with a constant speed, this will be a fixed quantity, meaning this will be a quantity that represents your motion. Similarly, um, for circular motion, you can represent a frequency, lowercase f, frequency. And for cyclical motion, any type of motion that involves starting at some point and then periodically coming back to that point, frequency is 1 over period. It's how many circles or cycles you accomplish in a given amount of time. So that is necessarily having an inverse relationship to period. So frequency has an inverse relationship to period. And with these two definitions, we can represent angular velocity, which these are both for uniform circular motion. Which is just a fancy way of saying constant angular velocity. Meaning frequency and period somehow tell me something about angular velocity. And the way this works is within one time around a circle, I know that I will complete an angular displacement. So, right, angular velocity is defined as angular displacement over the passage of time. But if I have a fixed angular velocity, then I can define the time part in terms of the period. And given this relationship over here, or the physical quantities we've defined over here, then once around a circle is what frequency and period are both referring to somehow. Then one time around a circle has an angular displacement of 2 pi radians. And necessarily, if I have a fixed constant velocity, then I will complete that in one period, is the amount of time that passes. So 2 pi radians over one period is equal to a constant angular velocity if you have a situation where you have a constant angular velocity. Given the relationship between frequency and period, that means that this is further equal to 2 pi radians times frequency. And in both cases, my units will be radians per second.